set of 3 trig questions. We often get questions with ladders and looking at the safe angle from the ground. Be very careful to label these correctly and draw a correct diagram. If they tell you it's a 3.8 metre ladder, then when you have a vertical wall and horizontal ground, then your 3.8 metre ladder will be this distance here. It's placed 1.8 metres from the wall. Find the angle the ladder makes with the ground. That is the angle between the ladder and the ground. That would be this one. Draw your diagram, label your sides, write your ratio, rearrange, oops, wrong ratio, and solve that. I have an angle of, if you're giving it as just degrees, you'd go to the nearest whole number, 62 degrees, unless otherwise requested. If you were giving it in degrees, minutes, seconds, of course you'd round it. Next half, the ideal angle is 75 degrees. Is the ladder correctly placed? Well, no, it's not. Is it too steep or is it too shallow? If you're a little uncertain, remember you can always draw yourself another diagram. If this should be 75, then a larger angle will be too steep, your ladder might tip over, and a smaller angle, which we've got here of 62, will be too shallow. And if you're giving an answer, justify it. A person measures the angle of elevation to the top of a tree 7 metres away as 62 degrees. If their eye height is 1.62 metres, find the height of the tree. This is a typical type of question we get. If they don't tell you the height of the person who's measuring it, you assume they're measuring it from their ground level, but in this case they're not. So this is our person here at 1.62 metres. They are standing 7 metres from a tree. Remember, trees, buildings, whatever, just draw it as a line. And we want to find the height of the tree. Of course, we need a right-angled triangle, so they look on the horizontal from their eye line, and then they look up to the top of the tree. They measure the angle of elevation as 62 degrees. X that we find in our triangle is going to be that. Again, you can redraw your triangle if you would like. If you want, you can always represent the length that we want to find as a different letter. So we find X, we have adjacent and opposite. Choose your ratio, substitute your values, rearrange, X is 13.17 meters, and you're finding the height of the tree, so you do have to add on the height of the person observing. Y equals X plus 1.62 equals 14.79 meters, and it was a word question. Find the height of the tree. Therefore, the height of the tree is 14.79 meters. Another standard type of question is two different observations of the same thing. A hiker finds the angle of elevation to a trig point to be 16 degrees. You always assume that you're walking on the horizontal unless otherwise told. So if it was she ascends a slope, then you're going up a slope, otherwise you're walking on the horizontal. So she measures this at 16 degrees, and it is a 563 metre high trig point. She walks closer to the mountain and measures the new angle at 38 degrees. How far did she walk? That is our x. Now, that is not a number that you can find right off, because that is not a part of a right-angled triangle. It is a part of a non-right-angled triangle, and we don't do that, not yet. So you will have to find y, the length of this triangle, z, the length of this triangle, and subtract them to get x. If you get confused, redraw your triangles. Here is your big triangle. Label your sides. Okay. Now we are in meters. So she's close to 2 kilometers from the trig point in a horizontal direction. Your small triangle has 38 degrees. And we're finding z, which is still going to be tan. Okay, 720.61 meters. So, you have found y, you have found z. X is y, take away z. Oops. And of course, as it was a word question, how far did she walk? Therefore, she walked, and would probably give that one to the nearest meter. And this is actually quite a useful navigation tool, by the way. A trig point will let you take measurements and calculate the distance you've walked. And if you knew you had to walk 1,500 meters before you changed direction on your navigation, this would be one way of keeping track.